Hello, Geography 212 students. I'd like to give you a little preview for exercise 2A. In exercise 2A, you're going to be looking at a lot of what we call station models, and you're looking at an example of one right up here on my whiteboard. So let me go through that and explain how we interpret the data off of a station model. So let's start first with just this circle. That's going to be exemplifying the location. For example, Prescott's Love Field, the airfield out there where our official weather station is. So the circle there, it's going to be give us an indication of what we call the sky cover. Sky cover is generally going to be the amount of cloud coverage. Now what I've done is I've hatchered that in. It would, if it was showing you correctly, it would be totally filled in as cloudy. If it's clear, if there's nothing in there, it's clear. So it's an indication of the amount of cloud coverage. Generally, we're looking at clear, scattered, partly cloudy, which is 50%, or totally cloud. Excuse me. Now, let's take a look at the wind here. This line here is indicating the wind direction. But what is extremely important for you to remember in meteorology, that the wind direction is always the direction that the wind is coming from. I can't stress how important that is. So it's the direction the wind is coming from. This particular line here is pointing toward the northwest. So we would say we have a northwesterly wind. Okay, so the wind direction is from the northwest. Now, these little, we call them feathers, are giving us an indication of the velocity or wind speed. When we see one long feather like this, that's an indication of 10 nautical miles per hour, and we use KNOTS to denote nautical miles per hour. Now, the difference between a nautical mile and a statute or land mile, the kind you read off your car speedometer, is that a nautical mile is equivalent to approximately 1.2 statute miles. But don't get too hung up about it. In meteorology, we use nautical miles per hour. So the long feather, 10 knots. Now, a half or short feather is worth 5 knots. So in this particular example, you'd simply add the 10 and the 5 together, and we'd say the wind speed is 15 knots. Okay, so to summarize the wind then, we have a northwest wind at 15 knots in this example here. All right, let's take a look at these numbers over here. The numbers over here, the top one, and this is by convention, you'll always see it like this in a station model. The top number is your current air temperature. In this case, it's 57 degrees Fahrenheit. The number below, we haven't talked about this yet, we'll get into this later in the course, is what we call the dew point, 56 degrees. All right, so 57 degrees air temperature, 56 degrees dew point. All right. Now this is very important over here, and this is the only one that's a little bit tricky. This is going to be giving you the current air pressure. Now in meteorology, on these surface weather maps that you're going to be looking at in 2A, you're going to be seeing air pressure a lot. Air pressure is given in what we call millibars. For those of you familiar with the metric system, a millibar is the equivalent of a hectopascal, but we also use just MB after the number. Now, to give you some idea of average air pressures on the planet Earth, our average sea level pressure is right around 1,013 millibars, okay? And one thing that's also very important to note, that at the surface of Earth, the air pressure doesn't vary between 950 and 1050 millibars. So we're going to end up somewhere in between there. So let's go back to this number. This doesn't look anything like 1013 millibars because we have to do something to it. First thing, number one, with a 3-digit number you're always going to see in the upper right, place a decimal point one place to the left. Okay? Now, we still don't have a number that looks anything like any of these numbers I've given you. So now what you have to do is you have to choose to put either a 9 or a 10 in front of this number here. Now, because I told you the range of barometric pressures, surface pressures at sea level on Earth, is between 950 and 1050. You've got to make that number there somewhere within that range. You do that by choosing either a 9 or a 10. And in this case, obviously, it's going to be a 10. All right. So what this is showing us is that the current barometric pressure at this station is 1010.7 millibars. Okay. Also, you'll have to go through the book and you can take a look. In this particular location, station models is what we see as weather. Weather, in terms of station models, generally is there precipitation. Rainfall, light rain would look like that sort of thing. So this is where your weather would be: rain, snow, fog, that kind of thing. All right. Well, hopefully that's enough to get you started. And most of 2A is going to be looking at information like this on surface analysis maps. Okay. So good luck with that, and I'll be talking to you again next week.